Hello everyone, my name is Tao Hong from China, from AOSA, and I'm also supported by CAASTRO. And I'm a first-year PhD student here, and I joined supervised by Jinling Han and Lister. So today I will talk something about two-mass Tully-Fisher survey. Okay, here comes the standard model again, and in our universe, we can just detect and see 4% of the matter directly by our eyes or telescopes. And if we want to detect the other 22% of dark matters, I mean, you can try to use new technologies and to build a new CCD or sensor to detect it directly. But the reasonable choice now is that we can detect this part of matter using the gravitational effect of these matters. So the main purpose of our project is try to mass all of this matter in our local universe. So okay, what's the two-mass Tully-Fisher survey or 2MTF project? We try to measure the distances, I mean the Tully-Fisher distances of nearby galaxies, and these galaxies are selected from the two-mass redshift survey. We have about 3,000 high quality H1 widths, and we also use near-infrared magnitudes to do the Tully-Fisher things. And the key point of this project is that we have very uniform sky coverage, and it is very useful for further cosmological analyzing. So basic idea of our project, I mean, the Tully-Fisher things and H1 things are described very well by Scott and Jacinta. The basic idea of this project is that the first step we will use the Tully-Fisher relation to get the redshift independent distance of these 3,000 of spirals. And then when you have this redshift independent distance, you can try to calculate the peculiar velocity of these galaxies. The peculiar velocity means that the difference between the true velocity of the galaxy and the velocity that you expected by the Hubble flow is given here. And then when you have this peculiar velocity field, you can use this field to transmass in the local universe. I mean, this mass is both visible matter and dark matter. We just use this gravitational effect of this mass. So about the source selection of our project, our purpose is to minimize the error in Tully-Fisher distance. So we require the galaxies are very bright. Bright means that you can have less near-infrared photometric error, and bright make everything easy to, and the bright galaxies are more easy to detect it in radio. And the second one, we ask for these galaxies are age-long, so you can get less H1 with error. So here comes the selection criteria. We select all of these galaxies from two-mass redshift survey, and 3 criteria here. First one is that in the KS band, it should be brighter than 11.25 Mach, and then should be nearby that the velocity should be less than 10,000 kilometers per second. The last one is that the axis ratio of these galaxies should be less than 0.5. That means these galaxies are age-long. So data, we use two different kinds of data. First one is the near-infrared data. Now the data is from two-mass, and we are also testing the WISE data to try to reduce, to get less scatter of our Tully-Fisher relation. And the second one is the H1 data. We have 3 parts of H1 data. First one is that we observed about 1,000 galaxies use GPT and PARCS. The second one is from the Alpha project. Alpha project is a blind H1 survey made by Arecibo, and it should be released this year, but nowadays they just released 40% of their data. And the third part is the archived data. We select this H1 information from other database or other paper, and these H1 data are also good enough for our Tully-Fisher distance measurement. And about the new observed galaxies, we use GPT and PARCS observed about 1,300 galaxies. GPT just observed in the northern sky and excluding the Alpha sky, because we expect that the Alpha will release their data very soon. And using position switching mode with 12.5 megahertz bandwidth and about 8,000 channels. In the southern sky, we use PARCS telescope using the beam switching mode with 7 beams, and the bandwidth is 8 megahertz and about 1,000 channels. Okay, this is the distribution of our new observed galaxies. These red ones are GPT galaxies, and in the southern are the PARCS galaxies. And these two areas are Alpha sky, so we do not do new observation here. Okay, this is our final sample. About 3,000 galaxies with uniform sky coverage, and these stars are archived data. Green dots are from the Alpha 40% database. And the current status of our project, most part of the data reducing things are finished, and the data is almost ready now. And I'm still working on some cosmological analyzing works. So this is conclusion. The 2-month Tully-Fisher survey is try to use both 21 centimeter radio information and near infrared data to calculate the Tully-Fisher distance for more than 3,000 galaxies with a very uniform sky coverage. And we want to build the peculiar velocity field to map the mass in local universe. The data is almost ready to use, and more work is coming in cosmological analyzing. So that's it. Thank you.